Newton's first law is known as the law of inertia. It states that an object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues in motion with the same speed in the same direction unless acted upon by an unbalanced force. This means that there is a natural tendency of objects to keep on doing what they're doing. All objects resist changes in their current state of motion. In the absence of any unbalanced force, an object in motion will maintain its motion. Let's look at an example of this. A person is sitting on the bed of a truck. The person driving the truck floors the accelerator, and the man consequently slides off the back of the truck and falls onto the ground. This is because the man, who was initially at rest, wants to, per se, stay in his initial state of motion, as opposed to go with the truck. Another example would be a kid on a skateboard. As he rides down a hill, he skates into a rock and his skateboard stops immediately. Due to inertia, the kid flies forward and off his skateboard. Unlike the man in the truck, he was initially in motion. Both people, however, maintained their initial state of motion. Newton's second law states that acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater amount of force needed to accelerate the object. This means that, well, in the most simplest of terms, heavier objects require more force to move the same distance as lighter objects. An example of this would be a man kicking a soccer ball. With some amount of force, the man is able to launch the soccer ball all the way across the field. Let's say with the same amount of force, the man kicks a building. The result is not exactly the same. Newton's second law also gives us the relationship of force equals mass times acceleration. Let's look at an example. Mike's car, which weighs 1,000 kilograms, is out of gas. Mike is trying to push the car to a gas station, and he can make the car go 0.05 meters per second. Using Newton's second law, you can compute how much force Mike is applying to the car. Since force is equal to 1,000 kilograms times 0.05 meters per second, the final answer you come up with is 50 newtons of force. According to Newton's third law, for every action there is an equal and opposite reaction. This means that for every force, there is a reaction force that is equal in size and opposite direction. Whenever an object pushes another object, it gets pushed back in the opposite direction equally as hard. A rocket is a perfect example. The rocket's action is to push down on the ground with its incredibly powerful engines. The reaction then is that the ground pushes the rocket upwards with an equal amount of force, launching it into the air. Another example would be an untied balloon. As the air rushes down, the reaction pushes the balloon in the opposite direction, flying it through the air. I hope this review has clearly explained the crucially important principles of Newton's laws. Thank you for watching.